Thank you very much for attending this session. Today I'm going to discuss one interface between finance and operations. I'm going to talk about throughput and inventory in terms of dollar. Translate what we said in operation into finance concepts. In this course, we assume supply is equal to demand, and what we produce, we sell it. Sales and production are equal. Also, sometimes flow time is referred to as days of supply. In financial concept, when we talk about throughput, we shouldn't use sales data. We should use cost of goods sold. Throughput is cost of goods sold, and inventory is average cost of inventory, or cost of goods sold. And cost of goods sold, usually we show it by CGS. Average cost of inventory. Revenue is gross sales. Revenue is not throughput. Cost of goods sold is throughput. Cost of goods sold and inventory are of the same nature. Sales or revenue has some profit in it which is not in inventory. Inventory is in terms of costs, therefore throughput should also be in terms of costs. Gross margin is the difference between revenue and cost of goods sold divided by revenue. Revenue minus cost of goods sold divided by revenue. Then if I take this revenue and divide it by this revenue, I'll get 1, and minus cost of goods sold divided by revenue. Both of these two formulas represent the same thing, which is gross margin. But of course, this one is easier for me. Inventory turn is a term defined by finance people, and that is throughput divided by average inventory. Throughput divided by average inventory. If we look at this, we may remember something. Throughput divided by average inventory. We also have something called average inventory divided by throughput, and we call it flow time. Inventory turns. Throughput divided by average inventory. Flow time, average inventory divided by throughput. Therefore, inventory turns is indeed 1 over flow time, or flow time is 1 over inventory turns. And we said when it goes to dollar, throughput is shown using cost of goods sold, not using revenue. Therefore, inventory turn is indeed cost of goods sold divided by inventory. Suppose total sales is 20 millions. Millions. Gross margin is 25%. Gross margin is equal to 0.25, and that is equal to 1 minus cost of goods sold divided by revenue. Divided by 20 million, right? Therefore, negative 0.75 is equal to cost of goods sold divided by 20, and therefore cost of goods sold is equal to 15 million. right? We simply wrote this equation and we just put here 20 and we solved one equation, one unknown. So cost of goods sold is equal to 15 million. That is our throughput. Inventory turn is equal to 7.5, and that is equal to cost of goods sold divided by average inventory. And cost of goods sold, we just computed it, was 15 million divided by inventory, and therefore average inventory in terms of dollars is $2 million. Gross margin is equal to 1 minus cost of goods sold divided by revenue. And the other equation we used was inventory turns is equal to throughput divided by inventory. And because we are talking in terms of dollars, throughput is cost of goods sold divided by inventory. We had this one and we had this one, then we computed this one. And then we had this one and we already have computed this one, then we were able to find inventory. And here I have typed all of this for you. So that is inventory. For how long a unit of inventory stays in the system? Inventory turns 7.5 times. That is how many times a single unit of product is replaced by another unit of product on average. Is 1 year, it is 7.5 for this much year. And if we multiply 1 over 7.5 by 12 months, that would be 1.6 months. And if I multiply this by 30, that would be 48 days. I mean, if a month is 30 days, if inventory turns is 7.5, each unit of inventory on average is there for 48 days. Some units are there just for 0 days, some unit for twice of 48 days, and on average they are there for 48 days. We can also look at it from a different angle. Inventory turn is defined as throughput divided by inventory. Flow time is defined as inventory divided by throughput. So flow time and inventory turns are reciprocal of each other's. And if inventory turn is 7.5, flow time is 1 over 7.5. 1 over 7.5 what? Because inventory turn was stated in terms of year, therefore 1 over 7.5 year. And if you multiply by 12, it would be in terms of month, and multiply by 30 in terms of days. We can also use the Lidl's law to show the same thing. Throughput times flow time is equal to inventory. Flow time is inventory divided by throughput. We have inventory. We have already computed it. It was $2 million. So that is the formula we have. T is equal to 2 million divided by throughput. Throughput was what? Cost of goods sold. And that is 2 divided by 15. 2 divided by 15 what? Year. If you multiply it by 12, 1.6 months. Suppose each product worth $100. Suppose inventory carrying cost is 20% of cost of inventory. So for each unit of product, if it is there for one full year, that would be 20% of $100, it is $20. Inventory carrying cost for one unit of product for 1 year is 0.2 times 100, $20. Compute total inventory carrying cost per year. There is a simple way to do it, and there is also a difficult way to do it. The difficult way is useful to understand the Lidl's law, to see something from different angles. Let me explain both of them. The first one is we have $2 million inventory. This is our total inventory. Inventory carrying cost is 20% of cost of inventory. $2 million cost of inventory, 20% of it carrying cost, that is $400,000 is inventory carrying cost. Cost of goods sold was $15 million, and each unit of product costs $100. So we have produced 150,000 units of product, and the total carrying cost of these products was 400,000. 400 divided by 150,000, and that is 2.67. That is one way. The other way is each product costs $100, and inventory carrying cost of that product is 20%. Therefore, it costs $20. So if one product is in inventory for 1 year, its cost is $20. But it is not there for 1 year because it is replaced by another product 7 times a year. Therefore, $20 divided by 7.5 will give me the same thing, 2.67. I mean, these are all the same things, but we can look at them from different angles. And the reason that I am going through more than one procedure is because I like to practice with you to understand the relationship between numbers. We can look at them from this angle and from another angle. We can also say if a unit of inventory is there for 12 months, its cost will be $20. But based on our computations, one unit of inventory, on average, it is there for 1.6 months. Average flow time is 1.6. Therefore, what is its cost? And that is 1.6 multiplied by 20 divided by 12. That is 0.4 multiplied by 20 divided by 3, and that is 8 divided by 3, which is 2.67. Different ways to do the same thing. But let me just summarize things that we need to know. We discussed this equation. Gross margin is equal to 1 minus cost of goods sold divided by revenue. We said throughput is cost of goods sold, not revenue. Inventory turns is equal to R throughput divided by average inventory. Flow time is equal to average inventory divided by throughput. So these are the reciprocal of each other. I think this is all the concepts that we discussed. Let's see if you can solve this problem. So the first thing we need to do is to compute throughput. 20,000 visitors are there, but only 90% of them go to this ride, and that is 18,000 per day. That is throughput. We said throughput can be computed per second, per minute, per hour, per day, per month, per year. So if I'm going to compute it per hour, because a day is 10 hours, I divide it by 10, and that would be 1800 per hour. And if I'm going to compute it per minute, I should divide this one by 60, and that would be 30 per minute. So 18,000 per day, 1800 per hour, and 30 per minute, they all have the same meaning. Throughput, all of them are flow time is equal to 4 minutes. Why I transformed this one into minute? Because this one is in minutes. Now I can write throughput times flow time is equal to inventory. Throughput is 30 per minute. Flow time is 4 minutes, and therefore inventory is equal to 120. On average, 120 people on these rides, right? On average, how many visitors are in each car? 8. So 120 divided by 8 is 15. We need 15 units of these cars. These numbers are not exact, especially in COVID-19 days, but let me dedicate this example to one of our students, Masis, who was also TA of this course, and he works at Universal Studios. Thank you for attending this session.